Okay, so square. We're probably the most familiar with squares and all the properties that come with a square. So go ahead and review the properties. So a square has all the properties of a parallelogram, a rectangle, and a rhombus. So here they are. I'm not going to bother reading through them for you. You can go ahead and do so. What makes a square different from a rhombus, though, a big one, is it has 4 right angles. That's different from a rhombus, and diagonals are congruent, also different from a rhombus. Okay, if a square had AD 11, so AD is 11, find each missing value. So we know we're going to have to use the Pythagorean theorem here to find these diagonals. So this side's 11. Now, the diagonal here, this one, is going to be the sum of 11 squared plus 11 squared, and then the square root. So 11 squared plus 11 squared equals my unknown squared. So I get 121 plus 121, 242 equals x squared. Take the square root. Get 15.5. So the entire diagonal is 15.5, making each half of it 7.7, roughly. Okay, so BC is 11, AC is 15.5, BD, same length, diagonals are the same length, EC, 7.7. Alright, so the angles. Now I know all the angles are right angles. Using the properties from before, I know that the diagonals are going to bisect each angle, making each of these angles 45. I know that the diagonals are perpendicular, making each interior angle 90. So angle DAB, 90 degrees. Angle AEB, 90 degrees. CBD, that's going to be 45 degrees, half of 90. And BAC, also 45 degrees. Alright, so you're going to try this one on your own. Remember, you're going to have to use the Pythagorean theorem to find the diagonals. Alright, so here, we know that this is a rhombus. So I need to find MP, which is this side. So a rhombus, all the sides will be congruent. I know opposite sides are also congruent. So I'm going to set 9x minus 77 equal to 3x plus 7. Okay, I'm going to solve for x. Alright, I know x is 14. I'm going to plug that in. I'm going to plug it in down here because this is a little easier to solve. 3 times 14 plus 7. I know once I have the side length PO, it'll be the same as all the other side lengths, so I can find MP. So I get PO equal to 49, also making MP equal to 49. Okay, the same idea with the angle bisector here because the diagonals bisect each angle. I'm going to move on to number 10. If STU is a square with SW being 2x plus 3 and WU 8x minus 41. So let's look at this. WU is the diagonal. SW is the other diagonal. I know that these two diagonals are equal to each other because they bisect each other. All the diagonals are equal to each other on a square. So I'm going to set these two problems equal to each other to find VT, the entire diagonal length. So 2x plus 13 equals 8x minus 41. Subtract 2x, add 41. I'll get x equals 9. Alright, I'm going to plug this back in to find the diagonal length. So let's find SW. Plug 9 in. I get 2 times 9 plus 13. 2 times 9 is 18. 18 plus 13 is 31. So SW is 31. That's half of the diagonal. I need the full diagonal length because all the diagonals are congruent. So if I find SU, that's the same length as VT. So if I double this, I will get 61, or 62, sorry, equals VT. So that concludes the notes on a square.